So section 4.4. Let's check the theorem and to find the function if it's concave up or down. Let f be a function now whose second derivative. And again, I told you we're gonna put section 4.3 and section 4.4, 4.5 together to graph the function. So now to find the function if it's concave up or down, we have to check the second derivative exists and open interval I. If the second derivative greater than 0, that means it's concave up. That means the function is like this. If the second derivative less than 0, that means negative, going to be concave down. This is just like a general graph. Now, the second part is the point of reflection. The points when the function change. Concave up, then concave down. That means the point at when the function change is going to be an inflection point. From concave down to concave up, the same thing, the point is called point of inflection. Or sometimes they're going to ask you, find the point of inflection. They're going to tell you, do the second derivative test. No, they're going to ask you, find the point of inflection. That means the function is concave up and down, or concave down, then concave up. Okay? Let's check a simple example, then trying to do a simple example. They ask you to find the problem interval in which the function f of x equals 15x squared minus x cubed is concave up or down. Concave up or down, that means second derivative. So the first thing, my function f of x equals 15x squared minus x cubed. The first derivative is going to be 30x minus 3x squared. I need to find the second derivative, so I can find the critical point where the function is concave up or down. The second derivative is going to be 30 minus 6x. This is the second derivative. Now I need to find the critical numbers. So I'm going to take the second derivative. 6x equal to 0. That's 30 is going to be 6x. Divide both sides by 6. So x is going to be equal to 5. So here is the critical number. Where the function is concave up or down or the opposite thing. Let's do a simple graph here because we're going to do the same thing. There's 5. Now my interval, this is polynomial. That means the domain for the polynomial, all the positive and negative numbers. So my domain is from negative infinity to positive infinity. Because it's polynomial. Here's my critical number. Now I'm going to pick any number here. Let's take the 6. So there's the second derivative. Here's my second derivative. For my second derivative, I'm going to find the x equal 30 minus 6x. Let's take a number here. Let's say, okay. Here I can get the 4. And here I can get the 6. Or you can take the 0 here. It's fine because this done the 5. That's mean f double prime to the 4 is going to be 30 minus 6 times 4, which is equal 30 minus 24, which is equal 6. It's a positive. That's mean from negative infinity to 5, the function is concave up. Now let's check the 6. So f double prime to the 6 is going to be equal 30 minus 6 times 6. So it's going to be 30 minus 36, which is equal to negative 6. It's a negative number. That means that from 5 to infinity, the function is conjugate down. We can write down the open intervals. From negative infinity to 5 is conjugate up. And from 5 to infinity is conjugate down. So this is only the test. Now, if I ask you to find the inflection point, that's me. Here is my critical number, which is only the x. I need to find the y, which is, you see, can give up, then down. So this is inflection point. So to find the y coordinate, we have to go back to the original function or the original polynomial here, 15x squared minus x cubed. So to find the y coordinate, I'm going to say f of x equal 15 x squared minus x cubed. So f to the 5 going to be 15 times 5 squared minus 5 cubed. Yeah, how much going to be 15 times 25 minus 125. 125. So 150, which is going to be the y coordinate. So 150. So the point is going to be 5, 250, which is the inflection point, where the function is going to get up and then we'll get it. So on the divide and circle, with the function, we have negative x cubed plus 6x squared minus 9x minus 7. It's conjugate up or down. So here's our function, which is f of the x equal negative x cubed plus 6x squared minus 9x minus 7. The first derivative is going to be negative 3x squared plus 12x minus 9. What about the second derivative? The second derivative going to be negative 6x plus 12. So I need to find the critical numbers. I'm going to take the second derivative equal to 0. For this one, it's going to be negative 6x equal negative 12. That's means x is going to be 4. So here is the critical number. That's the critical number is 2. Again, the domain is still polynomial. So my domain is negative infinity. It's positive infinity. And I have only one critical number. Now we can test the second derivative. So here is my second derivative. You have to be careful because when we graph, we're going to do exactly the same thing. We're going to find the increasing and decreasing. So we have to do the first derivative test. To find conjugate up and conjugate down, you have to do the second derivative test. So f of the x equal negative 6x plus 12. Now I'm going to take the number here, let's take 0. Because this is not 2. I'm going to take it any number here. I'm going to take 1, it's fine. So f double prime to the 0 going to be negative 6 times 0 plus 12. Which is equal 0 plus 12 going to be 12. So it's positive. That's me here. It's going to be conjugate up. And double prime to the 3 is going to be negative 6 times the 3 plus 12. Which is equal to negative 18 plus 12, which is negative. So it's negative. That's being the function is concave down. By the way, it doesn't matter. Sometimes you're going to go concave up and concave up. Concave down or concave down. So in this case, if you have concave up and concave down, this is an inflection point. Because the function is changed from up to down. But if you have both intervals on the up and up, that means there is no inflection points. To find the inflection points, so first of all, we're going to write down from negative infinity to the 2 is concave up, and from 2 to infinity is concave down. Find because now it's a inflection point. So up of the x will negative x cubed plus 6x squared minus 9x minus 7. Now f to the 2 negative 2 cubed plus 6 times 2 squared minus 9 times 2 minus 7.
It's three.
So 3, that's mean 2 on the 3 is the inflection point. So let's take this one. Find the open interval and want the function of the x equal 4 over x squared plus 1. Concave up or down. Now we have a quotient. So our function is 4 over x squared plus 1. Now we need to find the derivative. So f prime to the x is going to be equal. The bottom part times the derivative for the top, which is 0, plus or minus minus the top part, which is 4, times the derivative for the bottom part is 2x over x squared plus 1 squared. That's mean this one is going to be equal, that's prime to the x. So this is 0. It's going to be negative 8x over x squared plus 1. This is the first derivative. I have to find the second derivative. So the second derivative is going to be, it is the bottom part, which is x squared plus 1 squared times the derivative for the top part is negative 8 minus the top part, which is negative 8x times the derivative for the bottom part. The derivative here is in the power rule. It's 2 times the function 2 minus 1 is going to be 2 times the derivative of inside is going to be 2x. Everything now is divided by x squared plus 1 squared. Squared is going to be 4. Okay, now let's simplify this part. You see, this is only to find the derivative, not the critical numbers. Now we're going to simplify this one. I'm going to keep negative 8 on the parentheses. Here is going to be 8, 2 and 2, so negative 32 times negative is going to be positive 32. That's being fair. Double prime the x is going to be negative 8 x squared plus 1 squared x squared plus 1 squared plus 32x. Multiplying -8, 2 and 2. Negative, positive. 8 times 2 times 2 is going to be 32x. And here x plus x squared plus everything is divided by x squared plus 1 to the 4. Now we need to simplify it more. Yes or no? How are we going to simplify it? On the top part, do we have common?
Yeah.
So let's take the common out. That means add the double prime to the x. And then say x squared plus 1. What's the left? Here is going to be -8 and 1 parenthesis. Because we have 2 parentheses here. Let's take 1 out. The left is 1 parenthesis. Plus here is 2x. And everything divided by x squared plus 1 to the power 4. Cancel these. Okay, we have a cube. If we do the 8, so f double prime to the x is going to be equal to -8 x squared minus 8 plus 2x. Over x squared plus 1. So when I multiply here, -8x times x is x squared. So this one is 2. So now we combine these together. So it's going to be 24 x squared minus 8 over x squared plus 1. Now we can simplify, we can't simplify it anymore. So I'm going to find the critical numbers. I call the second derivative to the 0. Multiply this one, I multiply by x squared minus 8 plus 1. That's we're going to cancel this part. So the left is going to be 24 x squared minus 8. So go to the 0. Move the 8 to the other side. 24 x squared from 8 and divide by 24. So we do 1/3. That's mean x squared is going to be 1/3. Take the square root for both sides. So x is going to be plus or minus 1 over square root of it, which is equal 0.57. So you can know because you have to grab the line. How are you going to put these points?
2.57.
Yes. So 1 over square root of 3 is equal to 0.57.
Or and rounded is 5/8.
Yeah, it doesn't matter, but I just need to graph it. Okay. So when I put the line, I can know how to graph it. So this is only the critical number. Our second derivative is here. F double prime to the x is going to be equal to 24 x squared minus 8. Everything is over x squared plus 1. So here's our second derivative. So the main thing, I compare this number to a decimal, so I can know when I'm choosing the numbers between 1 over -1 over square root of 3 and 1 over square root of 3. So now It's negative 0.57. That's me. Can I choose -1 here? Yeah, so I can choose negative, there's negative infinity. I can choose -1 here. Between negative half and half, let's say, you can choose the 0. And here I can choose 1. So you always try to choose the easy number, the easiest number to plug in. So now, f simplifying to the -1 is going to be 24 times -1 squared minus 8 over -1 squared plus 1 cubed. And be careful when you plug it. So how much is going to be for this one? This is positive 24 minus 8. Okay, 16 over this one positive. 1 plus 1 is going to be 2. 2 cubed. So it's going to be 16 over 8, which is equal to 2 is positive. That's me. From here up. Plugging the 0. F simplifying to the 0, going to be equal 24 times 0 squared minus 8 over 0 squared plus 1. This is 0, so -8 over 1, which is equal to -8. So this one is coming here down. Let's check the 1. So f double prime to the 1 is going to be equal 24 times 1 squared minus 8 over 1 squared plus 1. Same thing, because this is positive, so on the top is going to be 16 over 8 and also over 2, which is the positive number. So this one is coming here. That's means from negative infinity to -1 over square root of 2 and from 1 over square root of 8. Sorry, not 2. To infinity, from negative infinity to this number, from this number to infinity, the function is Concavity. And from -1 over square root of 3, 1 over square root of 3 is from here down. Down from this one, and you'll see this one inflection point, and this one also inflection point because the function is changed from up to down and from down to up. To find the inflection points, we're gonna plug in the main equation, which is alpha fill x equal 4 over x squared plus 1. X squared plus 1. I'm gonna plug in this point. That's the f to the -1 over squared root of 3 is going to be 4 over -1 over square root of 3 squared plus 1. This is square, so it's going to be 1 over 3. That's be 4 over 1 over 3 plus 1. Add these together. So it's going to be 4 over 3 plus 1 over 3. Which is equal 4 over 4 over 3. Equal 4 times 3 over 4. That's mean our first point is -1 over square root of 3. Where 3 is an inflection point. And do the same thing with the positive But this one, it's going to be the same result because we have square. So f to the 1 over square root of 3. It's going to be 4 over 1 over square root of 3 squared plus 1. And it's going to be also 3. So the second inflection point is going to be 1 over square root of 3. With 3 is also an inflection. Find the open interval in which the function f of x equal x squared plus 1, x squared minus 1. So we're going to do exactly the same thing. So my function is f of x equal x squared plus 1 over x squared minus 1. Let's check to find the derivative of the x. So it's going to be the bottom part, which is x squared minus 1 times the derivative here, which is 2x. Minus, there's the top one, times the derivative for the bottom, also 2x. Everything now is divided by x squared minus 1. Let's try to simplify it. So if applying to the x is going to be, this one is going to be 2x cubed minus 2x. And we have here negative 2x times x squared, so it's going to be negative 2x cubed. Negative 2x times 1 is going to be negative 2x. In this case, this one positive, this one negative. Cancel these. Over x squared minus 1. F applied to the x is going to be negative 4x divided by x squared minus 1 squared. This is just the first derivative. I'm telling you, here's the important step when you're trying to find the derivative. Now we need to find the second derivative. Of x. Second derivative of x is going to be the bottom part times the derivative is going to be negative 4. So it's going to be x squared minus 1 squared times negative 4. Minus top part times the derivative for the bottom part. The top part is negative 4x. So here is negative 4x times 2 x squared minus 1 times the derivative of inside is 2x. And everything is going to be divided by x squared minus 1 squared is going to be to the power of 4. They do exactly the same thing. This one and this one are the same. So I'm going to multiply. Here is negative 4. And the second derivative is going to be negative 4. And here is x squared minus 1 squared. Negative negative is going to be positive. 4 times 2 plus 16 x squared and x squared minus 1. Everything is divided by x squared minus 1 to the power of 4. Now I have common here. Let's take the common out. It's x squared minus 1. On the left. On this side is negative 4. And x squared minus 1. Plus Just 16x squared. Everything is by x squared minus 1 to the power 4. Cancel these. This is the cube. Distribute this one. So the second derivative of the x is going to be negative 4x squared plus 4 plus 16x. And distribute negative 4 here. Everything divided by x squared minus 1. Combine the like terms here. Negative 4 plus 16 going to be 12. So 12 x squared plus 4 divided by x squared minus 1 cube. So here's our second derivative. To find the critical numbers, we take the second derivative and equal it to 0. Okay. So 12x to the squared plus 4 divided by x squared minus 1 cubed equal to 0. You multiply by this rational expression. You cancel the least common denominator, which is x squared minus 1 cubed. So the left is 12x squared plus 4 equal to 0. Move the 4 to the other side. So it's going to be 12x squared equal to negative 4. Divide by 12. So x squared is going to be 4 divided by 12 is going to be 1/3. What about the negative sign? Negative 1/3.
No,
It's going to be negative 1/3.
Yeah.
Then take the square root for both sides. So x is going to be plus or minus 1 over square root of 3. There's an I. Because when you take in the square root for the negative sign is an I. So now you have complex number. So this is a complex number. How are we going to graph? It's a critical numbers. The critical point here is x 1 over square root of 3i. So now write down this note. If you have rational function like this one, and you need to find, and your critical numbers is a complex number. In this case, you're gonna find the asymptotes. You're gonna put down the asymptotes as a critical number because the function is undefined at these numbers. And also the function is undefined when x equal positive or negative 1. So that's mean when you have rational expression and the critical numbers is a complex number, go ahead, that means there exists an asymptote for this function. Use the asymptote to test the second derivative. Now let's keep going. Again, our critical numbers is a complex number. So we're going to check the vertical asymptotes. How to find the vertical asymptote? We take the bottom part, which is x squared minus 1 cube equal to 0. And the cube both cube root on both sides. So x squared minus 1 equal to 0. That's the x squared equal to 1. So x is going to be plus or minus 1. So you're going to grab the asymptote because f is not continuous at 1 and negative 1. So we have to know f is not continuous at x of plus or minus 1. So we're going to test the second derivative at these 2 points. That's mean from negative infinity to negative 1 and from 1 to here's the one. It is this one. Okay, this one.
Which example are we doing?
So the same one. We'll finish the example. Because
Yeah,
our critical numbers is complex number. That's why I need to find the vertical asymptote,
but we looked the vertical asymptote in the secondary.
the second derivative,
Oh, I thought it was in the function.
the second derivative.
Okay.
So I'm gonna test these 2 points. For the second, no, we have to do it for the original function.
Yeah.
Because we need to find. You meant we need to find the vertical asymptote for the second, this one? No, we have to go back to the original.
No,
That's
that's
the question. I have to mention that here. Here is our original function of x equals x squared plus 1 and x squared minus 1. Because now we're gonna go back to the asymptote to this function. We're not gonna work with the derivative, the second derivative anymore. I add down here because I'm gonna use the test for the second derivative. When I test the asymptotes, also on the second derivative. For now, we're gonna test the second derivative for -1.
Yeah, but for the asymptotes, it will be different for the function. You found the asymptotes for the second derivative. That's one.
For the second derivative. First, so it will be x squared minus 1 equals 0. That's mean x squared equals 1. X of x is going to be plus or minus 1. We're gonna test the second derivative. I'm gonna take -2 here. We can take the 0 here. We can take the 2. The -2, we're gonna plug in -2 here for the second derivative. And then the second derivative of 0 and the second derivative of 2. Then these points. For -2, I think here it's going to be 12 times -2 squared plus 4 divided by -2 squared minus 1. This one is 4 minus 1 is going to be 3 cubed, going to be 27. This is 4, 12.8 would be 52. Okay, so the main thing is a positive number. That's mean. This is for the 2. So here it's going to be coming up. The same thing here. Also is going to be 52 over 27. Because -2 square and cancels for the same result. For the 0, it's going to be 12 times 0 plus 4 over 0 minus 1 cubed. 1 cubed. So it's going to be 4 over -1. As we have Concavity up here. Concavity down. Let's see. From -infinity to -1. And from 2 to infinity. And up. From -1 to 1 is they ask you find the inflection points. Have to plug in the one and here they ask you find the inflection points. You have to plug in -1 and 1 to check if it's the function on the up or down. Keep in your mind the function is not continuous here and here, so it's going to be separate. The function when you graph it is going to be separate here and here. So this one is not gonna consider inflection point. Because the function is not continuous at -1. And the function is not continuous at 1. There's like an asymptote, but here is gonna come here up, and here down, and here is going to be come here up. So in this case, we can find the inflection points, but the function is undefined at the asymptotes. So find the open interval in which the function of x equal x plus 2 cosecant x. And they're telling you, because now we're working with the radian, circles, they're telling you, okay, go ahead, walk between -pi and pi. And we need to find the interval, which is the function concave up or down. So now, here's my function of x equal x plus 2 cosecant x. Now I need to find the derivative. F prime to the x is going to be, this is 1 plus 2, the derivative for the cosecant. What's the derivative for cosecant? It's cosecant cotangent.
Negative cosecant.
Negative cosecant cotangent. Cotangent x. Now this one is going to be, this is the third derivative. It's going to be 1 minus 2 cosecant x cotangent x. To find the second derivative, be careful, we're gonna work with the radian here between -pi and pi. The second derivative to the x, this is 0. Check what I'm gonna do. I'm gonna find the second derivative. I'm gonna take -2 out. I'm gonna find the second derivative between cosecant and cotangent, two functions. So it's going to be the first one, which is cosecant x, times the derivative for the cotangent. The derivative for the cotangent is negative cosecant x. Yes or no?
Negative cosecant.
Squared. Negative cosecant squared to the x. Plus the second one is cotangent x times the derivative for the first one, which is the cosecant, which is going to be negative cosecant x cotangent x. See when we need to find the derivative? Now let's simplify this one. It's going to be f divided prime to the x equal -2 and negative. So it's going to be 2 cosecant cubed to the x plus minus cosecant x cotangent square. So here's our second derivative. Now we need to find the critical number. So I'm going to say, okay, here's my second derivative equal to the 0. 2 cosecant cube to the x minus cosecant x cotangent square equal to the 0. Here's the important thing. Check when the cosecant x equals 0, or when cosecant x cotangent square x equals 0, when this part minus this part equal to the 0. If you look to the cosecant x is 1 over sine x. Okay. So when x equals 0, which is between -pi and pi, cosecant x is undefined. Okay. For the same thing for this side. What about cotangent? Cotangent x equal cosine x divided by sine x. The same thing. When x equals 0, cotangent is undefined and cosecant is undefined. That means when x equals 0, it's an asymptote. It's an asymptote between negative pi and pi. In this case, I can't find the critical numbers here. But I have an asymptote, so I'm going to go ahead and check the asymptote. Check the asymptote. 0. Here is negative pi. Here's pi, not infinity, because we're checking here between negative pi and pi. So I'm going to choose here. You can choose -1, and you can choose here 1. I'll go ahead and plug in -1 here. And tell me it's going to be positive or negative. Then plug in 1 here. That means the second derivative of -1 is going to be, and the second derivative for 1 is going to be. Find if it's concave up or down. Again, you have to distribute the two. But I'm just looking to the cosine, cosecant, and cotangent. So here's, yeah, you're right, -2 times negative sign. This is still positive, but also you have to distribute -2 here. So negative and negative is going to be +2 or +2. Same thing. So now -1 and 1. This one is going to be negative, and this one is going to be positive. As a result, because you have to plug in, that means from negative pi to 0 is going to be concave down, and from 0 to pi is going to be concave up. So from negative pi to 0 is concave down. And from 0 to pi is, yeah, that's it. Do we have inflection points?
No,
No, why? Because
it's a asymptote.
asymptote is undefined. If you graph it, if you graph this one using the calculator, you will see like this, an asymptote here. Okay, if you graph this function, you will see an asymptote here, and the function look like this and this. So there is no inflection point because we test the 0, and the 0 is an asymptote.